All right, so let's look at the first question here is about the matrix. Okay, you can see there's like two matrices multiplied together. They have got some constants like A and B there. So matrix M represents a sequence of the two geometrical transformation. So state each of the transformation and we have to make clear about the order there. So for the first one that we have here is we have the multiplication of the matrices here. It actually means that this is actually what we do first, and this is what we do the second. Okay, so this is very important idea that we need to know. So for the first one, we can see it's actually a stretch because we have got like the A here. Okay, so it is a stretch in the x direction because like in the y direction, the 0, 1 will stay as the 0, 1. So it will be a stretch in the x direction. And for our case here, the scale factor is actually an A. Okay, it's a scale factor that is having an A. So we need to state everything very clearly here. Okay, although it's a 2 mark, so 1 mark for each of the transformation there. So everything has to be clear. So stretch in what direction and what is the scale factor. So that's for the first one. The second one is, okay, we need to make it clear by saying something like, say, followed by, right? So the second one that we see here is like, okay, the 1, 0 here stays as 1, 0 when we do the transformation. So whereas the 0, 1 has gone to the B1. So we know that this is actually a shear. So for this, you can actually measure that it's a shear. You can say either it's like in x direction, or you can say x-axis is fixed, okay? And then you just have to mention what is the factor from there. Okay, so that's for the part A. So in the second part here, we have got like unit square, okay, in this xy plane is transformed by M onto the parallelogram of the OPQR. So if like this, we have got a unit square becomes like a OPQR. So it is being transformed by using this matrix M here. Okay, so we need to find, okay, in terms of A and B, the matrix which transform the parallelogram to the unit square. So parallelogram back to the unit square is actually the M inverse, right? So we need to find out what is the M first by doing like the multiplication. And for the M inverse here, we can easily use the formula. Okay, so if this is M, so the M inverse here is 1 over AD minus BC, and then the matrix is something like this here. Okay, so that's for our part B. Whereas for the part C here, okay, now the area of this OPQR is 2 cm squared, and then the line is like this x plus 3y equals to 0 is invariant under the transformation which is represented by the M here. So we are going to solve for the A and B. So for A, it is related to the area. So from the square, okay, which is 1 cm square there, right? If we transform using the M, it gives us the OPQR. OPQR is actually like 2 cm square. So what is the scale factor? The scale factor that we have here is actually the modulus of the M. Okay, so the scale factor of the area here is the modulus M, not modulus M, sorry, determinant. So the determinant of M here is an A. Okay, we have already found the determinant here, which is AD minus BC, basically. So the A here is a 2. So this is very straightforward there. Whereas for the second one here, we actually have got like the line, okay, which is x plus 3y is invariant line. So when we look at that, right, is okay, this is our matrix M. So we know that, okay, we can use some like an equation here. So the matrix multiplied by some points, it is giving us the x prime and the y prime. So we really like find out what is the coordinate for the x prime and also the coordinate of the y prime. Okay, and from there, right, because for the invariant line, okay, is that invariant line, we have got some points x, y, okay, it must be on the line which is x plus 3y is equals to 0. And also because it is an invariant line, so it means that the x prime and the y prime, right, should also satisfy this equation here. Okay, it should also satisfy the equation of the line because the images, the x prime, y prime, should be on the line as well. So that is where we are actually considering using the x prime plus the 3y prime is equals to 0. Okay, so from there we will have like the x prime, we can substitute that x prime in, and then like for the y prime is actually the y. Okay, and also from the x and the y here, we know that the x is equals to negative 3y. Okay, so we have to sub in the x here with the negative 3y. So we can actually solve everything in terms of the y there. So because y is not something that we are interested to solve, so we will actually just look at the coefficient of the y is a 0. That will actually gives us the b is equal to 3. So in this case, it is not about like we try to solve the invariant line from scratch and try to find out that the m here is actually like -1/3. Okay, not using this way. Yeah, is we are already given the invariant line already. So we know that the images, okay, the images will satisfy the equation of our invariant line because these points should be on this line. Okay, so that's the way that we actually how we solve this. So that's for the question 1. Question 2. Use the standard result from the MF19 to show that, okay, we've got the result, like we want to find the ABC here. So basically, this is the stuff that is very straightforward. Okay, so expand everything, we get some expression in terms of the R squared there, and then we just have to sum in the values, the formula. This is sum of the R squared, this is sum of the R, and after that, because like we see this is a form, right? So very easy. After they just expand everything, then we will actually get like the expression which is like this. Okay, very straightforward. So for the next one is to like do okay the method of differences. So this one also something that we have been doing all the time. For this, okay, we know that we can actually write it as a partial fraction. So the partial fraction that we have is like 1/7 multiplied by this whole thing. Okay, so and then with that, okay, we will have to sum in the r equals to 1, 2, and so on until like the last term, the end here. So we can see how the terms actually cancels off. And we just need to give the final answer from here. Okay, so this gives us like the 4 marks there. Okay. So the part C, deduce the value of like, okay, when the n is approaching infinity. So when the n is approaching infinity, the reciprocal term that has an n here will approach a 0. The result is here, right? So this thing will actually becomes a 0. So we only have like 1/7 times 1/8, which the value that we have here will become 1/56. Okay, again, it's a deduce. So it doesn't really matter like the working that we have done. They just want to see the answer from there. Okay. So in this, okay, next one here is okay to find the cubic equation which is having the root of like the cubes of the alpha, beta, and the gamma. So as usual, let the new variable to be these roots here. Let's say the alpha cube, and then we make alpha as a subject, so we get like y power 1/3. And after that, we can sum in. Okay, so this is y itself because it's like the x cube here. This is actually y power 1/3. And from there, right, usually what we do here is we just want to move the terms which is without the fractional powers there to another side. So we have got like -y minus 1. And from here, because we need to get rid of the 1/3 here, so we cube both sides there. So once we cube both sides, this is what we get. And then the work that we got to do after that is just like we expand everything, okay? And we will just like rearrange from there. So we will get this equation here, right? So with that, we will have like, okay, the alpha power 6, beta power 6, and so on. Okay, for this is that we are not going to find the S6 from the original equation here because we know that in the new equation here, this one here, the roots are already being cubed there. So basically, this is just to find sort of like the S2 from using the new equation here. Okay, so with that, it's the same thing that I usually do here. I call all the new roots here as like the capital A, B, and C. Some books, they would like to use like the primes as well. It's up to you. So basically, this is actually find like the sum of squares of from the new equation here, this one. Okay, so just submit the values. Like this is the sum of the A squared minus 2 sum of the AB. Okay, so after that, just put in all the coefficients from there. Okay, and tidy up, and we're actually able to get this. Okay, so yeah, this is how we do the part B. Okay, so part C, find the real value of the C, okay, for which the matrix, okay, of this is singular. So from here, we need to really expand this matrix here by using the determinant here. Okay, so we can actually like work out the determinant. And as we actually look at like the terms there, right, there are some terms that we can collect together. which is like, okay, this is what we have found in the previous part, in the part B. And some more, this is our alpha, beta, gamma cube. Okay, this is to get from the part B. This one, okay, this one is to actually get from the original equation. That would be easier for us. I mean, you can get from the original equation, which is you recognize that as like an alpha, beta, gamma cube. You can do it like this, or this is the sum of the alpha, beta, gamma from the new equation, which is negative DOA, because the roots are already being like all the cube here. So when we actually multiply all the three roots together, it is a negative DOA. So you will get like a negative one from that. Okay. So from here, we can actually get this. Okay, determinant. So the question asks for singular. Singular means there's no inverse, means the determinant is a 0. From there, we just need to like find out what is the exact value for the C here. So it's a cube root of a 2. Okay. So that's the question. Okay. Vectors question. We have got 3 points, okay, and we want to find the equation of the ABC, the plane ABC. So the plane ABC is basically like 3 points, A, B, C, like that. So we want to find the normal from there. So the normal is to use any two of the vectors, okay, from the combination of everything like the ABC there. So for example, for myself, I'm using the AB and the AC here. So with these two vectors, we can actually cross them. So once we cross them already, we can actually get the normal of the plane. So from the normal of the plane, then we can actually use the r dot n equals to a dot n to find the equation of this plane here. Okay, it's a very common question, okay, that they will ask. And then for the part B here, so this is find the perpendicular distance from the origin to the plane ABC. You can see the question here is just 2 marks here, and you can see the space is very short. So it should be something that is very easy for us to find, right? In that case, okay, remember that there is a special property, like if we have got the equation of the plane here, we just need to divide both sides by the magnitude of the normal. Okay, when we divide by the magnitude of the normal, the right-hand side that we have here is the distance from the plane to the origin. Okay, so we just have to do that step. So like here, we are finding what is the magnitude of the normal here. So we use the right-hand side to divide by the magnitude of the normal. Okay, so this gives us like the distance very quickly here. Okay, so for the part C here is to find the acute angle between the two planes here. So is to find the normal, okay, between the angle between the normal of the two planes. ABC we already have the normal just now. Now we want to find the normal of the OAB. So what is the OAB? OAB. So if you want to find the normal for this plane OAB, we can use the OA to cross with the OB. So get this is a normal. So after that, we have got the normal from the first plane, normal from the second plane. We just have to do the dot product. So dot product, okay, 41 divided by the magnitude of each of the normal, and solve for the theta here. So for the theta, it gives us like a 36.2. Okay. So for this vector question, it's actually nothing like very special. Okay. Right. So let's look at this. This is okay a bit of the work to do, yeah, because we are going to like prove that this is the proof by mathematical induction. Okay, for every positive integer, we have got this result about the differentiation. So what we have in this case is that, as usual, Tn, okay, and when the n is equals to 1, we need to do two things here. One is we substitute into the right-hand side given, and we get some form which is like this. And at the same time, okay, we need to check, okay, do we really get this x plus a sine x? So we need to have something that to check against it. So in order for us to do that, we need to actually differentiate the x sine x from scratch. Because when the n is equals to 1, it is just a ddx only. So when we differentiate them from scratch, we are actually getting this. Okay, so it's proven that it is true already. So PK, okay, the assumption, everything, it's as usual. So we see what do we want to prove in this case is that when the n is a k plus 1, right? we are trying to prove something that has like a d. Okay, I use another color. So like d power 2k plus 1. Because when the n is k plus 1, right, when we evaluate, it's a d 2k plus 1 dx 2k plus 1. So it means that we need to do 2 times of the differentiation. Okay, so we are trying to prove for the derivative of like the x sin x, which is the 2k plus 1 derivative. So the 2k plus 1 derivative means we are differentiating 2 times on the, so you can see this is the d2k minus 1 over dx 2k minus 1. So we need to do 2 times of the differentiation from there. Okay, and before we do the differentiation, we could factorize the negative one out. It's not relating to the differentiation at all. So we do first time of the differentiation. Okay, we do first time. So x cos x, we use the product rule, we get this. 2x minus 1 sine theta, we actually get this. Okay, we do it, we do the first time from there. So before we need to, before we can do the next round of the differentiation, we can collect the cos term together first, tidy up. So we get like 2k cos x. So we need to differentiate it one more time. So as we differentiate that one more time, okay, what we have in our case here is that we will have like the product rule again. 2k cos x becomes like a negative 2k sin x. So here we see we can actually factorize the negative one out. And inside there, we just have to tidy up. Okay, so the negative one, when we multiply by the k minus 1 here, is a k. So this is something that we want to prove already. Okay, so we're reaching this result here. So pk plus 1 is true, and then we just have to make the conclusion from that. Right? Yeah. So okay. Rational graph is we have got this function. Okay, so it's very obvious that we need to do the long division. Okay, so once we do the long division, this is what we get. Okay, so from the part that we actually have like done this long division, everything here, it allows us to get the asymptotes very easily. Okay, and then another one is to show that okay, some values for the y here, so no points when the y is in between 1 and 5. So in that case, what we have is we will have to rearrange from the equation. So of course, it will be easier if we start from this form rather than the form that we actually have done the long division there. So we want to express that equation into some equation that is in terms of x, but with all the y's, okay, as the coefficients there. And because the question says no point, so we are using the b squared minus 4ac is less than 0 to do that. So of course, from here, we can actually prove the results here already. Okay, so our y here is in between negative 1 and 5. Okay, this is a wrong diagram, yeah. Supposedly it should be like this. Hey, wait. Hey, yeah, sorry, it's correct. I thought it's wrong. Okay, so this is the diagram here. Okay. Okay, and then after that, okay. So find the coordinates of the intersection of C with the axis and sketch the C. So we let the x to be 0, we get this. And when we let the y to be 0, we get these, okay, values here. So because they want the coordinate, so we really have to like write down in the coordinate form. And after that, it's just to transfer them into the graph there. Okay, so we know that, okay, we have got like the turning point, okay, at, because they say there is no point in between like the 1 and 5. So from here, we know that the turning point here should occur at the 1 and the 5. This is a 1, this is a 5, this is a 1. Okay, and also like we know that we have got like 2 x-intercept, right? So the lower part of the curve should actually be like touching here, the 2 intercept here. So of course we need to like mark those points there. Okay, so of course like this kind of the graph we already know one. If it is not having 2 turning point like this, then it will be something like this. Okay, but in this case, it will be the case that we have got the turning point. Okay, because we have already proven that the y, there's no nothing in between 1 and 5. So they must be having like the 1 and a 5 there for the y that has the turning point. Okay. So for the following, no more question from there. Okay. Oh, yeah, sorry, the part D. So sketch the curve with this equation. Okay, so basically what we got to do is just reflect whatever that is at the bottom, okay, to up there. Okay, so that's how we get the graph. So like I said, it will be helpful, right, if we actually like try to reflect this asymptote as well. So this part we can actually reflect it as well. And from there, right, when we actually try to sketch it, then we know that okay, our curve can actually go like this. Okay, so it will help us quite a bit in the sketching. So that would be the question lah. Okay. I think this is the last one. So yeah, the polar usually carries like a lot of the marks nowadays. So show that this Cartesian equation having this polar equation r is equals to sine 4 theta. So quite a bit of the thing that we need to do from there. So here, everything is quite obvious already. We have got a lot of the x squared plus y squared, which is the r squared itself. Okay. And also like for like the xy is like r cos and the r sine. Xy here, we can also put in like the r cos and also the r sine there. Okay, so from here, the right hand side there, right? We just have to like multiply everything, this one. Multiply everything from there first. And this cos square theta minus the sine square theta, okay, it can be written as like a cos 2 theta. So why do we do that is because in the end there's no theta already. It would be something like 4 theta. So you're just trying to like make it into some expression that has like 2 theta here first. And then what we can do here is we can cancel the r power 4. So left hand side is just nice. We get just 1 r from there. And when we look at like this is a 2 sine theta cos theta, right? So we can actually make this to become like a sine 2 theta cos 2 theta. So now everything when we combine is very nice. So it's 2 sine 2 theta cos 2 theta, which we can also write another round of the double angle. So this is like a sine 4 theta at the end. Okay. Okay, so for part B is to sketch, okay, the polar equation that is having this function. The theta is from 0 to 1 over 4 pi. So we need to sketch the C and state the equation of the line of the symmetry. So for the sine 4 theta, right, as we actually look at like the trigo graph of the sine 4 theta, we know that for the sine 4 theta, right, it's like this when it's from 1 to the 1 over 4 pi. And then this value here is 1 over 8 pi. Okay, and we know that this value is the highest value, which is at the 1 here. So we know, okay, the symmetrical part would be like the theta is equals to 1 over 8 pi. And it will be a loop because when theta is 0, the r is 0. When theta is pi over 4, the r is also a 0. So we know that it's actually a loop like this. That, okay, we will see that the curve is actually symmetrical at this theta is equals to 1 over 8 pi here. Okay, so we also need to like state, yeah, what is the line of the symmetry here is theta equals to 1 over 8 times a pi. Okay, so for this one, okay, is to find the exact value of the area, okay, of the region which is enclosed by the sea. So this is some usual integration that we actually did quite a lot. So square the r, okay, and what are we considering here is, okay, you can use from 0 to 1 over 4 pi, which is the whole thing. But for myself here, I think I can use like the symmetrical. So I use a 2 to multiply by the area, which is from 0 to 1 over 8 pi. Okay, you can just use like half integrate from 0 to 1 over 4 pi also. It's the same thing. Okay, so sine square 4 theta, we need to change that to the double angle. Okay, so once we have it in a double angle already, then it should be very straightforward for us to integrate. So after we integrate, plug in everything, okay, and from there, we will just have some very nice value here. Okay, so the area that we have here is a 1 over 16 pi. Okay, so after that, okay, so this is the thing. So after that, okay, is to use this identity, okay, to find the maximum distance of the C from the line, which is like theta equals to half pi. Give your answer correct to 2 decimal places. So we see they are asking again for maximum distance from the theta equals to 1 over 2 pi. Theta equals to 1 over 2 pi is our x-axis. So if you want to find the maximum distance from the x-axis, in this case, it is actually referred to the maximum x. Okay, so from the x here, okay, we know that it's a r cos theta, and our r here is a sine 4 theta. So here they already give us the identity. So the sine 4 theta is actually this whole thing, right? Sub that in. Okay, and then only from there we do the differentiation. So when we trying to do the differentiation here, you have different choices here. But for myself here, I'm just doing it straight away. Like the first term here, I actually do the product rule. Second term here, I also do the product rule from there. Okay, so with that, there might be something that we could tidy up nicely when we do the differentiation, that we can actually have this. Okay, so we want to solve for that theta. So we let the dx theta to be the 0. So it's either the cos theta is equals to 0, but we are going to consider that because the theta here is a pi over 2. It gives us like a minimum, sort of like a minimum x there. So we don't want that. So we will just look at the other equation here. So for this other equation here, when we simplify, we actually get something like this. Okay. There are different ways for us to look at, okay, in terms of like solving this equation here. One way for us to look at it is we change everything to in terms of the tangent. So how do we achieve that is we divide the whole equation by sine power 4. So we get something which is in terms of the tangent, okay? But this one, when we solve the equation here, right, it's in terms of the tangent square theta. So for the tangent square theta, we are using the formula to actually get that. So we have got 7 plus minus 41/4. But we are supposed to solve for the tangent theta here. So the tangent theta here, we need to bring in like the plus and minus. Okay. And then from there, right, okay, we will have like different values of the theta here. Okay. So the so like remember, yeah, the theta here is only from 0 to 1/4 pi. Yeah, the question actually mentioned that. Okay. Yeah, 0 to 1/4 pi. So when we solve for the theta here, right, from the tangent, no matter it's like plus minus of this or plus minus of the positive root here, right, we will only give the theta which is in 0 to 2 pi over 4. Other than that, we don't want. Okay, so we do not know yet, okay, what is like the maximum distance that we have from here. Okay, so that is where we just have to substitute the theta into the x to do the checking. Okay, so we found out that okay, this is actually the maximum distance. So we have got like this is the 0.929. Okay, so for this one, right, it's very difficult for us to use the second derivative. So the dx theta, if we do the second derivative, then it will be quite a lot. So that is the reason why we don't want to do that. And we will just turn to like, okay, maybe we just like sub in the value of the theta. So since they are actually not a lot, we can sub in the value of the theta here, okay, in order for us to look at like the maximum of like the x here. Okay. In fact, right, I think I have actually included this one wrongly as well because the value of the pi over 4, right? Okay, just check, yeah, what is the numerical value for that? So pi over 4 is 0.78. So this, even like for this one, we don't need to include that anymore. So there's only one value at the end. Yeah. So you can just take this value without like doing the checking. So yeah, the maximum distance that we have for this case here is this distance, okay, 0.929. Right?